Let's take a look at a Schmitt Trigger. Now, Otto H. Schmitt, who was born in 1913, died in 1998. He was a biophysicist, and he invented the Schmitt Trigger, a differential amplifier, and the chopper stabilized amplifier. Now, being a biophysicist, he worked with electrical impulses and nerves, but he invented the Schmitt Trigger. Now, the Schmitt Trigger is a circuit that adds hysteresis. So a Schmitt Trigger is a circuit in which the output turns on when the input voltage reaches a certain threshold and turns off when the input voltage falls below a certain threshold. And this is the transfer function here, and it shows the hysteresis loop. And you'll see this symbol when in the Schmitt Triggers. When you see a Schmitt Trigger on a diagram, you'll see that symbol inside the Schmitt Trigger. Now, Schmitt Trigger is not a component or device, it's an actual circuit, okay? So you can make it with a transistor, or you can do it with a comparator. Now, if you look online and buy a Schmitt Trigger, you'll probably come across a Texas Instruments 74HC 7014. Now, what that is, it's a buffer with a Schmitt Trigger input, and it has a built-in hysteresis between 0.55 times your VCC and 0.65 times the VCC. It has one input and one output on each of the Schmitt Triggers in there. There's 6 of them in a package. But they come in handy. And one thing you can do with them is make a square wave output. You put 5 volts DC in and you get your square wave out with just one resistor and one capacitor. So in this case I have a 1K ohm resistor and a 100 picofarad capacitor. Now, to find the frequency of the square wave, you take you take 1.2 times your time constant, RC, and divide that into 1. Now, this 1.2, this is it gives you a ballpark figure. Now, they take the 1.2 because we have the capacitor charges and discharges because there's a hysteresis in there. So that's why we're using this 1.2. Now, sometimes if you know a K value for the circuit, you'll have a K value that you divide in there. Usually it'll be less than 1. But in this case, when I did the math on here, it came out to 8.3 megahertz, okay? So I actually put that on the scope, built that up, and here it is, a little square wave here. Now, it turns out that this was 8.56 megahertz, but it close enough, you know, that gives you in the ballpark. And it has some ringing on here. Now, you know, 8.5 megahertz is probably a little bit too much to use with do it on a breadboard. That's what I did. I just built the circuit up on a breadboard, but there's some capacitance in there on the breadboard that kind of messes up the square wave there. But so use it for a square wave, and you can also use it to debounce a switch. So when you turn a switch on, you'll get ringing, and that can mess with your circuit. So you had a little Schmitt Trigger here, and that smooths out the switch. Now I did a video on that, and I'll link that in the description for that video. So you can make a Schmitt Trigger with transistors, okay, just like this. Easy to do, and in this case I used a JFET here, but you can use a transistor there instead. And then on my last video we did a comparator with hysteresis, and all that is that's a Schmitt Trigger. Okay, so that's it for a Schmitt Trigger. It's just a circuit that gives you a hysteresis, so it works out good. And that's it for a Schmitt Trigger. Thank you.